So does anyone else need any more help, or should I just start? Okay. All right. All right. So first step, you're going to be here in the screen. Everything is going to happen in simulation right here. So click that. All right. Next step, new study. And then when you get here, these are all this is a pretty fun spot. You get a lot of different types of finite element analysis you can do. We're going to start with a simple one, just static. Yo, what's good, Torn? Welcome in. Just in time. So yeah, we're just going to do the static study. I'll show you the other ones quickly later at the end, but for now, let's do static. And once you're in that, let me know if I'm going too fast because I might. Okay, yeah. So you do new study, static study, and then you'll be here from the simulation tab. Yeah, I can. Maj fixed it all, thank God. I don't know how. Yeah. Well, you said you did like the outside intersect. That's what it was. Did you got it? You got it? Okay. Okay.
Yeah, it's like
Okay, no worries. All right. So the next step is fixed geometry. So like basically for any finite element analysis, you have to like fix it somewhere else. It's gonna like now you imagine like if this is our drone, someone's got to hold it so we can put force on it. You know. What's good, Chaitan? Welcome in. Yeah, that's true. Yeah. Okay, cool. That's the guy I was talking to you about. Yeah. So then we're gonna fix the geometry. And how I was doing it is basically just on the center line. We're just gonna assume that the drone is in stable, steady flight and it's fixed along the center. So I'm actually gonna highlight every single one of these lines. I don't know if you have to do all of them. That's just what I do. But pretty much just like center line, just like click all of them until it looks like this. And yeah, let me know if you need any help. All right, am I moving that? Oh yeah. So yeah, yeah, fixed geometry. And then you use yeah. Do you have the Okay. Okay, cool. And then yeah, you're already getting that. All right, so in static study and fix it all down the center, yeah. Okay. Okay, cool. I think everybody is caught up for the most part. So we'll go ahead and click yes. And now something that you always have to do is you have to set the material. So I think when you downloaded it, you might have already had custom plastic, but this is like, and this is actually a custom plastic that's set to be PLA because that's what we're going to be making out of. However, you might make it out of something different. So if you right click the material and go apply edit material, it's going to give you pretty much every material in existence, at least that, SolidWorks knows about. So something that, is cool. A lot of our seaplanes get made out of balsa wood. So if you look up BAL or balsa, you can make it out of wood and hit apply and boom, now it's made out of wood. You can do a popular one that pretty much everybody uses is 1060 alloy aluminum. That's another one. Or basic alloy steel. These are all like common materials that everything's made out of. You guys probably know that. So, but yeah, for the purposes of this study, I'm going to do custom plastic just because that's.
So you just keep it as what it already is?
Yeah, you can keep it as what it is. It's really whatever you guys want to do, but custom plastic is the one that is most accurate to it, like a 3D printed part, for example.
The one that's already applied on the.
I believe so. Yeah. It should already have a material assigned to it. Okay. So now everyone's good. Everyone's good? Okay. The next step is to apply a load. So we've got it fixed, we've got a material, we need a load. So you can right click external loads, and it's going to bring up pretty much every type of force out there. A nice easy one that we can do is gravity. There's going to be gravity. So you just click gravity and you just click check. It's got 9.81 already in there for you. Done. Gravity is assigned. You can right click it again. And we're going to do pressure just because, as you say, we're in a 60-degree bank angle turn. We've got 3 Gs of force, and that's going to put some pressure on our wingtips. So if you look under the plane, there's actually these 2 surfaces that I've put in here that we can select. And this is just going to model basically the edge of the wingtip. In reality, this force would be distributed evenly along the entire wing, but for this just makes it easy for us to select it. So go ahead and select those 2 forces, and then we need to assign a value to it. So here it says Newton meters, but we're in America, so I use PSI. And yeah, so I just 3 PSI should be adequate. There's probably a way to like map it out to see exactly what PSI would go under this. Yeah. Are you good? Okay.
Is it 3 PSI?
Yeah, 3 PSI. That's all I need. Okay, and now this is where it's going to get a little hard for you guys on the laptops, but it should be fine. ANSYS is going to be a lot worse. So we're going to make a mesh, and please right-click the mesh and click Create Mesh. And let's go slow here because I don't want to crash anyone's laptop. The first thing is to click on Mesh Parameters. And then when you do that, we're going to go Standard Mesh.
Can you repeat that? So
Yeah.
You right click on mesh. What is it?
Yeah, here, I'll go back. Mesh, right-click Mesh, Create Mesh. Yeah, I'll let everybody do that. All right, Create Mesh. So there's a lot of things to click here. Mesh Parameters is going to open up all the different, because basically any kind of finite element analysis, what it is you're breaking up a lot of complicated problems or like one big complicated problem into like infinite tiny small problems that makes it easier for the computer to solve. And the meshing is what's doing that. So if we do standard mesh, this is like the dumbest, easiest, biggest mesh we can do. And then so click standard mesh, and that's gonna just make like basically evenly distribute the meshes, whatever it's called. And then you drag it all the way to the left, to this coarse value, and then you click check. And then once you do that, hopefully everyone's computers are okay. Just got to run a little bit, but boom. Yeah, it's going to be on. Didn't crash. Good. Now, in your own free time, you're free to do, I recommend the blended curvature mesh that was there. It's like the default value. And then you can even crank it all the way up to the high mode. And it might take longer to run, but just for this purposes, we're just going to make it nice and simple. So this one is the most inaccurate. This is going to give you... The blended one is going to basically... It caters to... This is a lot of like curves. Basically, this whole thing is made in curves. So you probably want blended curve or curve-based mesh. And it's going to... basically like along this chord line, it would put a lot of little tiny triangles. Like I'll just show you real quick. It might, hopefully it doesn't crash, but let's do blended curve. Yeah, I'll just show you. And it'll change how the mesh is created. And so like in yours, it'll probably look like a big even distribution, but in this one, well, so it looks a little different, right?
Yeah.
Yeah, and you can always up the values, and then you can see it actually like now it's all like a shark bit or something, because that's how it models it now, and that's what it is in the mesh. So yeah, so you can do whatever mesh you want. It's not it does affect the accuracy though. Yeah. So then we'll go ahead and apply. The load is applied. The frame is fixed. We have our material. We did the mesh. Now for the fun part, you get to click the big button up here that says Run this study. And hopefully it'll all work for everybody. If we did everything right. Oh yeah. Just click yes on that. There you go. You got it. Yeah. So we've now modeled a wingtip, and that's the load happened. Yeah. Make sure to click yes when it tells you that you broke it. Ignore that. Okay. Oh yeah, do pressure, not force. But yeah, it should give you the same result if you did force. Oh, they can go. It's you just click it and it auto does it for you. Here, I'll show you. I did fixed. And then I clicked every single one of these lines down the center. I just click it and like leave it as default under fixed geometry. Yeah. Yep. Okay. So yeah, so that's the basis of it. There's a lot more, obviously, that we can do. So let's get some values out of this because this is just a pretty picture. If you do edit definition, or you can do define stress plot, that's probably a little better. If you right click results and do define stress plot, it'll show you all the different types of stresses that you can apply. So you'll probably learn this in machine design about von Mises stress. That's like a pretty standardized stress to get some values out of. But one that I would be interested in here. So we see that the wings they're pulling up, right? Well, I want to look at that in the y direction. So I'm going to look at SY, y normal stress. And then I'm going to basically just click check on that. And now it's going to show me a different plot. And what's really useful about this is it shows me right here. That's where the weak point is in this design for this joint. Like it would probably fail right around there. Also, another thing that this study shows you is that you could probably use some spars. If we had like in our design, we're going to have long carbon fiber tubes throughout the entire wingspan that would mitigate this force, hopefully.
So
yeah,
this study is not taking into account the orientation of how you print the part.
Correct. Yep. Nope. It doesn't. Yeah. This model is assuming an entirely solid block of plastic. So our actual design is very hollow and very thin too. Like we're talking very thin walls. So this is more of a demonstration than like what we would actually what are like accurate results, you know. But it still tells us good ideas in terms of where to reinforce our design. Yeah, so then that's pretty much it for this one. Now there's a lot of other analysis we can use. We have 7 more minutes. So if we go back to model, I'll show you guys just a few more FEA studies that are useful, not really for drones, but are useful for pretty much everything else. So if you go back to new study, we're going to make a buckling. Well, let's see here. Yeah, let's do the buckling load. Buckling. Yeah. Oh, yeah, you can save it. Yeah, at the end, we'll actually generate an entire report, and then it'll show you all the numbers. Yeah. Yep, go back to that, and then we'll do buckling. And buckling is more used for like bridges and like trusses and stuff. So, oh, sorry. This bottom right. Yeah. My bad. Right down here, the bottom of model. You click that, and then go back to new study, and then it gives you all the studies you need. We're gonna do buckling real quick. And just click buckling, click check, and then we're going to do the exact same thing that we just did. We're going to fix it along the same line all over again. And this one I'm just going to run through a little faster just so we can move on to the ANSYS. But yeah, just fix it. And then we're going to put the load. And yeah, I'm just going to put a force this time. You don't have to do gravity if you don't want to. I'm just going to put a force here. And then I could probably put a force over here. And you can kind of click around, just have fun, see what happens basically. And then once it's fixed, and here's another fancy little fun thing you can try. I'll show you guys is you don't always have to make your own mesh. You can save a little time by just clicking the mesh and run button. And it might take a little longer to run, but you don't have to manually make a mesh. It'll just mesh it and run it in one swoop. So Yeah, and then this one, I remember it looks really weird. I don't know why. But if this was a truss, it would look better. But that's a whole nother lesson, I guess. Let's see here. Okay, this is because I didn't do the course mesh. It's going to take a little longer to run. There it goes. Come on. Oh man. Oh, there you go. Yeah, that's what it's supposed to look like. Yeah. I don't know why it does that. Yeah. But yeah, it basically just shows you that like in it. So say, basically what it's doing is it wants to know where is the part going to break under load. And so it says that if there's a pressure here, it will likely break at that top right red part. And you can right click and animate it too. I forgot to show you guys that. And it'll like move it. Oh, I just like, I think just like standard, like, I think like probably like 1 Newton. Yeah. If you right click the study, the amplitude, it's actually a lot more interesting if you look at the animation for the static one. You can make it flap like a bird. Yeah. So it's yeah. Okay, and in the last 3 minutes, I feel like a professor that's run out of time. I will show you guys the thermal one, or no, not the thermal one, the vibration one, frequency. This one is actually really useful for aerospace hardware. Any plane, as it's flying really fast, is going to undergo a lot of stresses, vibrational stresses. And this one's a lot easier. All you have to do is fix it, and then you can run it. So if you go back to the studies and choose frequency, it's at the very top, right under a static. And then when you fix it, and then you actually, once you fix it, I'm pretty sure you can just mesh and run it. But I'll lower the mesh just so it runs a little faster. Okay. And yeah, and then once it does that, it'll show you a bunch of frequencies, and it's pretty useful. Okay, so yeah, sorry I went a little fast at the end, but that's everything. So yeah, then it's got all the different types of frequencies. You can see there, and this last one's pretty funky if I remember. Yeah. Where's the weird one? Huh. Well, okay, so yeah, it's basically just like showing different vibrations of different parts of the drone. Yeah. It's just like imagine if you were like holding the drone and you were like shaking it really hard. It's like the different types of vibrations it would feel. And so the very last thing that we're going to do is basically generate a report. Anytime you do an FEA analysis, you probably want a report to go along with it. Get some pictures, get some data from it. So if you click on report, pretty much from any of the studies, whichever study you're in, static, buckling, or frequency, that's the report it's going to make just for that one. And then you can just click publish, and it's going to take a long time, but it will make a pretty detailed stuff that's useful. It's all automatic, and it does it in Word. Yeah, so that's it. That's all I got for you guys. Thanks for that. Now, thank you. Yeah, and then I'll hand it over to Maj, and we'll do some answers. Yeah. Yeah, I'll give you the HDMI. Yeah. Oh, you got your own. Okay. No worries. Yeah.
I forgot this was today for you guys.
Yeah, no. Yeah, this is